Okay, welcome to this class. Let us look at this question. I'm going to paste the question on the screen, but what you are asked to do is to find the velocity ratio of the jack because you are dealing with meshing and that is under spool. So another one is we are asked to find the mechanical advantage and then effort required to raise the load and the work done by the effort in raising the load. So what I'm going to let you know is few things when it comes to a screw or bolt and nut or jack, anything that can turn is what I'm talking about. So what is the velocity ratio? But before then, I want you to pick this. When we talk about work done, you are talking about work output. You understand? Because the main thing is for you to do work with that machine. So what is the output is exactly what we call by work done. And another one is this, work done by the effort. Look at this. And whenever we are talking about effort, we are talking about the work input. Whatever the effort is doing is the input into the machine. So effort times circumference of the handle is equal to the load times the pitch. So it's definitely, this is the work done, or what, let's say work input, and this is the work what output, which is the load times the pitch. And I'm also going to let you know that when we talk about the pitch, we're talking about the distance between the successive screws, right? Then that is all about. So when we talk about velocity ratio is going to be equal to 2 pi r all over p. So what should be the r, the radius? You are not going to see the radius, whether you are going to see the length of the handle. Therefore, the r is equal to length of the handle. So that is how it will come. So these are the things I want you to know before we start our calculation, and a few other things I'm going to be telling us as we proceed with the solution. So let's go with the first one, which is velocity ratio. If you look at the question, we have velocity ratio is going to be equal to 2 times pi is 22 over 7 times what is the length of the handle. If you look at the question says whose pitch is 4.4. okay, so p okay, let's say that p is equal to 4.4 millimeter. Now this 4.4 millimeter, I have to convert it to meter because remember, radius, I mean this is length base, you have to convert to millimeter. So converting it to millimeter, we're going to have that we divide it by 1000, and we're going to say that pitch is equal to 0.0044 meters. So that is the pitch, then which is all over this 0.0044, then times the radius, the r, which is the length of the handle. So according to the question, the length of the handle is given as the length of the tummy bar. In this case, they are given the length of the tummy bar if you are reading the question, and it is given as 70 cm. So 70 cm, so r is 70. I'm going to divide it, 70 cm divided by 100, I'm going to have 0.7. So I'm going to times 0.7. So velocity ratio is given as, let's do the calculation by having, so this is also good. Okay, if I do that, I'm going to have 2 times 2 all over 7 times 7 over 10 all over 0.0044. So this is going to cancel this, and this is going to be 44. This times this is 44 divided by 10, which is 4.4. Then velocity ratio is going to be 4.4 divided by 0.0044, which is 1000. Okay, this cancel this, yes, 1000. So this is the velocity ratio of this question. So the next question here is, for us to find the mechanical advantage. All right, remember that mechanical advantage is equal to load over effort. Load over effort. So in this case, what is load? From the question, load is 800 kg. That is 8,000 kg. I'm going to call it, I'm going to say 8,000 times 10. I'm going to express it in Newton. All over, what is the effort? We are not giving the effort. Okay, for that reason, since we are not giving effort, I'm going to find mechanical advantage from efficiency formula. So remember, efficiency is given as mechanical advantage all over velocity ratio times 100% over 1. So from this question, efficiency is given as 80%. So I'm going to have 80 over 100 is equal to, I do not know mechanical advantage, but I have velocity ratio given. So mechanical advantage all over 1000. I'm not going to multiply by 100 again because 100 is already here. So I'm going to have 2 zeros cancel, 2 zeros cancel. So I'm having that mechanical advantage is equal to 800. So that is my mechanical advantage. Okay. So the next question is effort required to raise the load. Now I have mechanical advantage. I have load. I can find effort. Okay. Effort required to raise the load. So let me clean up. So I'm going to have that this is number 1. Remember, this is number 2. Number 3, effort. This is number 3 here, which is effort. Effort is given as load over mechanical advantage. Yes, load over mechanical advantage. That is my effort. So what is the load? Load is 8,000. Let me multiply it by 10 to express it in Newton times 10 all over. Mechanical advantage is 800. This will cancel this. I have that effort is given as 100 Newton. So effort is 100 Newton. So the last one I'm going to do is called work done by the effort in raising the load. So work done by the effort in raising the load. What I'm going to do is, let's take it from here. Work done by the effort in raising the load. Now at this point, work done is same thing as work input. Okay, this work done is same thing as work output, right? So in this case, I'm going to have that. I'm going to say that efficiency is equal to work output. So work output all over work input times 100% over 1. So the efficiency, which is the work done by the effort, that is work input. Work done by the effort should be work input, not work output. So I'm going to do this. I'm going to say that work input, which is work in, is equal to work output all over efficiency times 100 over 1. Yeah, and this is going to be equal to work output. Our work output is going to be, okay, let me handle it here. So our work output, which I'm going to find, is going to be distance work output. Remember, work is force times distance. Work output is going to be load times distance. Okay, so because of the voice note, voice had issues, so I'm going to be doing this voiceover. So load times distance moved by load. That is going to be the work output. And the load is 8,000, but I'm going to express it in Newton by multiplying by 10. It becomes 80,000. So I'm going to ask for the distance moved by load. If you look at the question, distance moved by load is going to be, it said through a height of 20 cm. It's going to be 20 cm. I'm going to convert it to meter by dividing by 100. So when I cancel this, try to do some simplification. I have, this is going to be 2 times 8 is going to be 16. How many is 1 to 3? 1 to 3 joules. So that is going to be the work output. So let's go back to where I'm putting it. Work output is going to be 16,000 divided by the efficiency, which is already given as 80. Efficiency is given as 800 times 100. If I do the simplification, you'll divide this by Yes, when I cancel 0, 0, I'm going to have 2 zeros, 1, 2, 3. How many zeros? It's going to be about 5 zeros. Okay, 4 zeros. And that is the question when we say the work done by the effort in raising the load. And please don't forget to hit the subscribe button, like this video, share it, and comment.